In this PPT, you are going to see conversion of an ER diagram to relational tables. So previously we have seen that how to draw an ER diagram and what is an entity and what is an entity sets and what is a primary key, how to represent each and everything in the ER diagram. We have seen that, and now in this relational model we are going to see how we are going to convert an ER diagram into relational tables. So primary keys allows entity sets and relationship sets to be expressed uniformly as tables which represent the contents of the database. A database which conforms to an ER diagram can be represented by a collection of tables. For each entity set and relationship set, there is a unique table which is assigned the name of the corresponding entity set or relationship set. So, converting an ER diagram to a table format is the basis for deriving a relational database designed from an ER diagram. Entity type. So, we are going to see some important points in conversion. The first step point you have to keep it in mind is entity type becomes a table. In the given ER diagram, lecturer, student, subject, and course. So, all these things are going to be called as the individual tables. So, all these entity type will become a table. And then, second important type, all single valued attribute becomes a column for the table. In the student entity, student name and student ID form the column of student table. Similarly, course name and course ID form the column of course table, and so on. Next step, a key attribute of the entity type represented by the primary key. In the given ER diagram, course ID, student ID, subject ID and lecture ID are the key attributes of the entity. Next one is the multi-valued attribute is represented by a separate table. In the student table, a hobby is a multi-valued attribute. So, it is not possible to represent multiple values in a single column of student table. Hence, we create a table student hobby with column name, student ID and hobby. Next step, composite attribute represented by components. In the given ER diagram, student address is a composite attribute. It contains city, pin, door number, street and state. In the student table, these attributes can merge as an individual column. Next step is derived attributes are not considered in the table. In the student table, age it is going to be derived, is called as the derived attribute, since we can derive the age from the date of birth. So it is a derived attribute. It can be calculated at any point of time by calculating the difference between current date and date of birth. Using all these rules, we can convert the ER diagram to tables and columns and assign the mapping between the tables.